Hello students, welcome you to this session. We are studying two-dimensional analytical geometry in which conic section. Already we studied parabola. Hope you understood all those things. And try to understand all the concepts, then you do the sums. And in this video, I am going to teach ellipse. All the basics and what are the formula and what are the concepts you have to remember, everything I will be teaching in this video. Okay. So in the next video, we'll discuss the sums. You can understand it very easily. So you know conics, there are three types of conics: parabola, ellipse and hyperbola. Depends on the eccentricity value, right? For parabola, the eccentricity is 1. For ellipse, eccentricity less than 1, but it cannot be negative, so it lies between 0 and 1. So 0 less than eccentricity, E less than 1. Okay. So eccentricity lies between 0 and 1. Then for hyperbola, eccentricity is more than 1. Then we studied parabola, the standard equation derivation I taught. Then how many types parabola we studied? There are 4 types of parabola, right? But in ellipse, there are 2 types of ellipse. First I'll give some of the result, then we go for the proofs. Okay. So ellipse, the standard equation of ellipse is x square by a square plus y square by b square equal to 1. For parabola, it is the standard one is y square equal to 4x. Okay. Then for other types, you know what changes we made. So this is the first type ellipse, and its diagram will be like this. Okay. So this is the diagram. This is an ellipse. Second type standard equation is x square by a square plus y square by b square equal to 1. Then you may ask, right, what is the difference, right? So here the difference is depends on the denominator. You should see the denominator. Both will be of the same type only, x square by y square by. Then you see the denominator here, suppose x square by, this is the greater number. So this is 25 and this is 16. Greater, smaller. First type. The second case, x square by, that will be the smaller number. For example, it is 9 and this is some 25 like that. So greater, smaller, first type, smaller, greater, second type. Okay, otherwise it looks similar only. But in the formula and all it will change. I'll tell you what changes you have to make. And for this, the second type, the diagram will be like this. Okay, so understand there are 2 types of ellipse. Equation x square by plus y square by equal to 1. Denominator you should see. Greater, smaller, first type. Smaller, greater, second type. Okay. Then diagram. So first one is like this. So this axis is called major axis. So this is x-axis. This axis we call it as major axis. And the other axis, the shorter one, we call it as what? Minor axis. So, and this point is the center. And here this is one axis, this is another axis. So here major axis is along y-axis in the second case. In the first type, major axis, the longer one, that is the major axis. Major axis is along x-axis or parallel to x-axis. That is the first type. And the second type, major axis is along y-axis or parallel to y-axis. That we see. There are 2 types. In parabola also we studied 4 types, right? So actually there are 3 set of formula. One set when the vertex is what? 0, 0. Another set when the vertex is what? h, k. Same way here also we have 2 set of formula. 2 types and 2 set of formula. In one set, that is a basic one, if the center is 0, 0, there vertex 0, 0, but here the center is 0, 0. If the center is 0, 0, we have a set of result. And another set, when the center is h, k, that's not a problem. If you know the basics, that is when the center is 0, 0, then what change you make? Already in parabola we did that, right? X value you add h and y value add k. The same thing we are going to use it for ellipse and even for hyperbola. Okay, so this is some just brief introduction about ellipse. And you know the eccentricity, 0 less than e less than 1. Eccentricity always lies between what? 0 and 1. See, x square by 12 plus y square by 16 equal to 1. Which type ellipse this one? x square by plus y square by. See, 12 and 16 you should see, right? Smaller, greater. So this is second type. Suppose it is 121, x square by 121, y greater, smaller. So this is of the first type. And you see the diagram, okay? Okay, that is the first one. Now, let us see the first type in detail. What are the formula you have to study here? And the standard equation I said x square by a square plus y square by b square equal to 1. Later part I will help you how to find the equation. The derivation also I will teach you. Now listen here, this is the first type ellipse. So you know first type means x square by a square, and that a square is the greater one, right? Plus y square by b square equal to 1, and this is the greater number and this is the smaller number. So C is the center. Center is here 0, 0. A dash along x-axis, right? A dash is called the major axis. A dash is major axis and B dash is minor axis. A dash, the full length is 2a. A dash, the full length is what? 2a. So length of the major axis is what? 2a. Then length of the minor axis, that is B dash, is equal to 2b. So these formula you remember. So can you tell me what is the length of CA then? Semi-major axis, half of that, right? Major axis length is 2a. So CA means half of that. Semi-major axis, so it is what? A. Same way this length will be B. Okay, so that is A and B. There are two foci. For parabola only one focus, right? But for ellipse there are two foci. One is here, that is S. And another focus is here, S dash. There are two foci. For every focus there is a directrix. So for the focus S, there is a directrix. Say this is the directrix. I am taking it as, say, DD dash. So this is the one directrix, DD dash. So whenever you use this focus, you have to use only this directrix. So this directrix is corresponding to the focus S. And I said there is one more focus, right? What's other focus? S dash. And for that focus, there is another directrix in the other side. We take that as a D1 and D1 dash. So, okay. So whenever you use this focus, second focus, S dash, you have to use this directrix. Okay. Now some more lengths I'll tell you. First one I said the length of A dash. What is the length of A dash? 2a. C is the center. Center, what's the formula? 0, 0. Can you tell me the value of A? A is called vertex. A and A dash are two vertices. So one by one formula you study. Okay. So center, you know, center is 0, 0. There are two vertices. One is A, another one is what? A dash. Here, the first type, the vertices lies on x-axis. So its y-coordinates will be 0, right? Y-coordinate is 0. And the x-coordinate, this length is what? A. Here also same length A, but since it is the left side, you have to write minus A, right? So one vertex is A, 0. Another vertex is minus A, 0. So this is another formula, A, 0 and minus A, 0. Okay. So few formula you studied. Now focus. There are two focus. S is one focus. CS, this length is AE. CS, the length is what? AE. In our book, that AE, they have taken a small c. Okay, that is used later. So CS equal to AE. So can you tell me the coordinate of S? S is the focus. Focus also lies on x-axis, so its y-coordinate also 0. So it is AE, 0. And another one is, since it is the left side, minus AE, 0. Okay, so there are two foci. One is AE, 0, and the other one is minus AE, 0. And that AE, they have taken a C. AE, they taken a C. So in that case, you can say it is what? C, 0 and minus C, 0. So remember, C stands for what? AE. AE only we take it as what? C. Okay, so if you study center, focus, vertices, then how to find lattice spectrum I'll tell you. But before that, one more length I'll tell you. The directrix. So axis is x-axis, right? Major axis is along x-axis. X-axis and the directrix meeting at a point, say Z, and here this one you take it as Z dash. So then this length is A by E. This length is what? A by E. So can you tell me that equation of directrix? Directrix is parallel to y-axis. So equation is x equal to constant, right? X equal to constant. Here that constant is what? A by E. So the equation is x equal to A by E, and for another directrix, it is x equal to minus A by E. X equal to minus A by E. Okay, now please listen. From C, you have to say the distances. Okay. C to S, what's the distance? C to S. AE, because focus is AE, right? So C to S, it is AE. C to A, C to A, it is A, right? Semi-major axis, C to A, it is A. What is C to Z? A by E. So these three, very, very important. Remember, when you do the sums, you need all these things. Can you tell me the distance between two foci? Distance between two foci, that is S and S dash, this full distance. What is that distance? 2AE, right? Because C to S, this is AE, this is also AE. So distance between two foci is equal to 2AE. Distance between the vertices, A to A dash, A plus 8 is 2A, right? Length of the major axis. Length of the minor axis is 2B. Then can you tell me the distance between two directrix? There are two directrix, right? So this distance is A by E. This distance is A by E. This is also A by E. So distance between the two directrix, it is 2 times A by E. Okay, 2 times A by E. So these are the results you have to remember. Okay, and few more I'll give you. Length of the lattice rectum, equation of lattice rectum, that will take separately. Okay, so hope you understood all these things. So diagram, and once you know the first type, second type is very easy. What change you make, I'll tell you. Then if the vertex is not 0, 0, if the vertex is at, not vertex, center. If the center is at h comma k, very simple, you know how to do that. For x you add h, for y you add what? K. Okay, hope you understood. Now let us see. For the second type, what changes you have to make. So finally, we consolidate all the results. Don't worry, we'll go through that one more time. See, this is the second type, right? So its equation will be x square by plus y square by equal to 1. You see the denominator is, right? So for which type? For x square by y square, see the denominator. Greater, smaller. First type, smaller, greater, second type, right? So in here, it may be something like this, 16 and say 64, something like that. First one, x square's denominator is smaller. Okay. And here another very important thing, which one to be taken as a? Which one to be taken as a square? There, x square by a square. First one's denominator a square, second one denominator b square if it is the first type. Here, the greater number you take it as a square. Greater number you take it as a square. See, it's very, very important. So how you are taking, based on that only I'm going to give the formula. So here you take one method, formula, you learn something else, totally you will be confused. So learn one method, learn perfectly. You should not have even a 0.1% doubt. Okay, so the greater number you take it as a square is very important. And 64 is a square, and the smaller one is what? B square. Okay, so using this one, I'm going to give the results. Okay, see, now it's you can say what is center? 0, 0. So this is the major axis now, A dash. The length of that major axis is what? 2A. Length minor axis BB dash. Can you say the vertex? In the first type, what's the vertex? Just now we studied, right? First type, what's the vertex? A comma 0 minus A comma 0, right? Vertices. A comma 0 minus A comma 0. Can you tell me here? The vertices lies on which axis? Y axis. So x coordinate must be 0. So instead of A comma 0, you write what? 0 comma A, right? So the vertices are 0 comma A and 0 comma minus A. There are two foci, S and S dash. There we studied focus AE comma 0, right? First type AE comma 0 and minus AE comma 0. AE only I said to take it as what? C, right? Then you write C comma 0 minus C comma 0. But here 0 comma C. Why? Because it lies on y-axis. So x coordinate is 0. 0 comma C and 0 comma minus C. C is same as AE. Okay, so remember that. Then for this focus, yes, there is a directrix, and for this focus there is another directrix. Okay, so other things and all you can write. Only thing, equation you should change. For the first type equation directrix, we said x equal to a by e and x equal to minus a by e. First type. For the second type, this is the second type, right? Instead of x, you put y. That's the only difference you should make. Because this is the directrix dd dash. Directrix is parallel to x-axis. Parallel to x-axis means y equal to constant. Y equal to constant. Instead of x, you have to write what? Y. So learn one set of result thoroughly. Then you see what changes you have to make. That's all. Easily you can do that. Okay. So hope you understood that. Now one other very important property you have to study. That is called focal property. So they can ask state and prove focal property, or sometimes they will give the statement, they'll ask you to prove it. And when you do the sums also, you need that. Okay. So focal property, just to explain to you what it is. Look at this. Focal property, the sum of the focal distances. Sum of the focal distances. What do you mean by that? Focal distances means distances from the focus. Foci. Here there are two focus, right? There are two foci. So from both the focus, you can draw the distances to a point. To for what? The sum of the focal distances of any point on the ellipse is equal to length of the major axis. Length of the major axis. What is major axis? A dash. What is the length? 2a. So we have to prove equal to 2a. Sum of the focal distances of any point on the ellipse. So please listen. You take any point on the ellipse. See, I am taking a point P here. I am taking a point P. Then focus, there are two focus. One is S, another one is what? S dash. Focal distances means you have to join, right? This focus, this is one focal distance. What is first focal distance? SP, right? SP is one focal distance. Another focal distance is S dash P. So these are the two focal distances. Now what they said in the question, sum, that means you have to add it. So that is, SP is one focal distance, S is one focus, from that focus to the point SP. Another focal distance is S dash P. The sum, you add it, and your answer is length of the major axis. Length of the major axis means what? It is what? 2a. So this is focal property. The sum of the focal distances of any point on the ellipse. So P can be anywhere in the ellipse. Okay, it can be anywhere. Then S and P are two fixed points, right? Focus, it is a fixed point. Okay. So focal, the P, when P moves, the focal distances changes, right? But still, SP plus S dash P will be always what? 2a. So this is a focal property for ellipse. Later we will study focal property for hyperbola. Okay, little bit different. That we'll see later. So focal property means you have to be very careful. You have to see the question very carefully. Focal property of what? Whether they asked ellipse or hyperbola. For focal property of ellipse, the sum of the focal distances equal to length of the major axis. That is SP plus S dash P is equal to 2a. Now I am going to give the proof for this. Okay. Now please listen. Whenever we talk about focus, you have to look into the directrix also, right? So there are two focus. So for the first focus, there is a directrix. So I'm okay, and for the second focus, there is another directrix, okay? So these are the two directrices. I'm taking the first one as DD dash. Second one is D1, D1 dash. And this point is Z, and the left side it is what? Z dash. All the distances you know. Shall we recall one more time? C to S, what's the distance? C to S. C is the center. Center is 0, 0. C to S, it is AE. C to A, it is A. C to Z, that is sender to directories A by E, right? Okay. Now, we have to find SP plus S dash P, right? But conic, there is a formula. SP by PM, right? SP by PM equal to E. SP by PM. When you use this focus, you use this directrix. When you use the first focus, you have to use that directrix. Listen. When you use this focus, you have to use this directrix, okay? So SP by PM equal to E. Okay, that is one result. SP by PM equal to E. So from that you can find SP, right? Cross multiply, you will get SP. We need SP, right? We need SP. And one more we need, S dash P. S dash P. So now I'm going to take this focus. When you take this focus, you use this directrix. So once again, I'm going to use SP by PM. But instead of S, we are using S dash, right? So what you can say, S dash P by P, use this directrix now, right? So at that point, I'm taking it as, say, M dash. We take that one as what? M dash. So now you can say S dash P. S dash P by PM dash is equal to E. If you cross multiply, you will get S dash P also. Then you have to add that too. Are you able to understand? Okay. P is a point, anywhere you can take in the ellipse. Then SP by PM equal to E, there where M is the perpendicular distance to that directrix. Then you take S dash. When you take S dash, you take the second directrix, D1 dash, right? So S dash P by PM dash is E. From both you cross multiply, you will get the values of, see the first one, you are getting SP by PM equal to E. So cross multiply, SP is equal to E into PM, equation number 1. Second one, S dash P, right? S dash P by PM dash equal to E. You cross multiply this, S dash P is equal to E into PM dash. Equation number 2. We have to find the sum, right? So adding equation 1 plus equation 2. SP plus S dash P is equal to, take E common, PM plus PM dash. That is E into PM plus PM dash. Look at the diagram. Look at the diagram, try to find out PM plus PM dash what it is. PM, this length, plus PM dash, this length. So PM plus PM dash means the full length, that is mm dash, right? It is mm dash, E into mm dash. That is E into, please listen, what is mm dash? Mm dash, this full length is equal to this length, right? Mm dash looks like a rectangle only, no, right? Mm dash is same as Z dash. Mm dash is equal to what? Z dash. That is E into, please listen, Z dash, the full length, right? Z dash means what? Z is in the first one directrix, Z dash is in the another directrix. Actually, that is the distance between two directrix, right? Center to directrix, what is that? A by E. So this is A by E and that is also A by E. So the total distance is 2 times A by E. Or if you want, you write Z dash can be written as 2 times CZ, right? 2 times this length, right? 2 times this length. So you can do like that, okay? So 2 times CZ. That is E into 2 into CZ is A by E. CZ is A by E. Already said I asked you to remember, but when I give the derivation, I'll give the proof also, how it is A by E. Okay. Now here you can cancel this E and E. So what you are getting? 2A. So what you got now? SP plus S dash P equal to 2A. That is sum of the focal distances equal to length of the major axis. What is length of the major axis? 2A. Hope you understood this. So the property also you study, learn the property, also learn the proof also you study. Okay. Now listen. Now I'm going to teach the derivation. Very simple only, just listen very carefully. So hope you understood the diagram. You are thorough with the diagram now. And I have taken some more points, nothing, only I have taken a point P. So first type ellipse. S is the focus. It is what? AE comma 0. How you are getting? I'll tell you. So in this, when you do the derivation, we are going to get all the proofs. Why the focus is AE comma 0 and why that C Z is A by E. Everything we are going to see. Okay. So C is the center. A dash is equal to what? A dash is 2A, right? Okay. Then please listen here. SP by PM is E. SP by PM is equal to what? E. P is a point on the ellipse. It can be anywhere. P can be here, or P can be here, or P can be even here. So in particular, P may coincide with A. So in that case, if P is here, you say SP by PM. If P is here, you say SP by PM. If P is here, SP by PM. What is that? SA by AZ. So we are going to say SA by AZ, right? SA by AZ. Are you able to understand this step? SA by AZ equal to E, because A is a point. A is a point on the ellipse. A is a point on the ellipse. So instead of P, it is A. That's all. SP by PM. Instead of A, since A is there, SA by AZ. Okay. Now, same way you can see another point, A dash. A dash also a point on the ellipse. So, SA dash by, see, if P is here, what you write? SP by PM. PM means you draw perpendicular to the directrix. Don't look, sir, this is very close, sir, I will go there. No. Whenever you use this focus, you have to go this directrix only. So, SP by PM, like that only you should go, right? So, when I take this A dash, even though it is here, S A dash divided by, this is like our SP, by PM, that is this A dash to directrix. So, that is this full length, right? So, yes, A dash by A dash is at equal to E. Listen. Suppose when P is somewhere here, so P is somewhere here, what you say? SP by PM, you draw a perpendicular, like, right? Like that only we do, no? Same way only, suppose the point coincide with this A dash. Then what you say? Yes, A dash by A dash is at. Yes, A dash by A dash is equal to E. So these are the two major things you have to understand. Okay. So the 2 points, we take the point A and A dash, both lie on the ellipse. So it satisfies that condition SP by PM equal to E. Instead of P, first time we take A, second time instead of P we take what? A dash. Okay. So now listen, cross multiply, you are getting these two results. SA is equal to E into AZ. SA dash equal to E into A dash Z. Now, just stage by stage you remember. Now you are going to add the two equations, then you are going to subtract the two equations. Okay. So first you add these two, SA plus SA dash. Equal to right side you add E into AZ plus E into A dash Z. Take E common, AZ plus A dash Z. See the diagram, SA plus SA dash. SA plus SA dash. If you add these two, you will get the full length. What is the full length? A dash. And what is A dash? 2A, right? You will get A dash, and that A dash is equal to what? 2A. That is the left side part. But right side, A is Z plus A dash is Z. A is Z. A is Z we don't know. So what I am going to do, A is Z and A dash is Z we want. A is Z and A dash is Z. Now please listen, you write in terms of C. You write in terms of C. A Z can be written as CZ minus CA. So A Z is equal to CZ minus CA. CZ minus CA. And the another one what you need, next one what you need is what? A dash Z. So where is A dash Z? A dash is at the full length, right? The full length can be written as, in terms of C, you write CA dash plus CZ. CA dash plus CZ. So these two values we are substituting. Okay, that value only we have substituted here. Now you see, you can cancel this CA dash and CA. Why? Both the lengths are equal, CA dash and CA. CA dash, CA and CA dash. Both the lengths are equal. One is plus, one is minus. So they get cancelled. Then what do you have? CZ plus CZ. What is that? 2CZ. Both the sides you cancel 2. So CZ is equal to A by E. CZ is equal to what? A by E. This is one of the very important results. CZ equal to A by E. Now you know CZ is equal to A by E. How you got it, right? CZ is equal to A by E. Now, so now that two equations we added, you got one result. Now we subtract them. So when you subtract, you see which is greater. One is SA, another one is SA dash. SA and SA dash, right? SA, another one is SA dash. So which is greater? SA dash is greater. So adding no problem. But when you subtract the greater one, so equation 2 minus equation 1. Equation 2 minus equation 1. SA dash minus SA equal to E into. So take E common. A dash is at minus A is at. Now here, right side you can simplify. A dash is at minus A is at. See, A dash is at minus A is at. So from A dash is at, if you remove that A is at, you will get A dash, right? You will get A dash. So the right side value is what? A dash. So this part is A dash, this is A dash, and A dash is equal to what? 2A. So right side is simplified. Now here left side there is a problem. We want SA dash minus SA. SA dash and SA, both we want. So since we don't know, see SA dash, what is SA dash? Write in terms of C. CA dash plus CS, right? CA dash plus CS. Then SA, this is SA, right? How can you write SA in terms of C? CA minus CS. CA minus CS. Okay, these are the two values you substitute here. Since there is a minus sign, so here you put the minus and you put a bracket. So remove that bracket, you are getting this. Here also you can cancel CA dash and minus CA. CS plus CS is what? 2CS equal to 2AE. Cancel 2 on both sides. CS equal to AE. CS equal to AE. Listen, look at the diagram. CS means which length? CS. This length, right? CS equal to AE. That is the reason this S is AE comma 0. So hope you understood the focus, how we are getting it is AE comma 0, and the directrix, the distance is A by E, because for the proof you need all these things. Okay, so now you know focus, then P is a point on the ellipse. So now use SP by PM equal to what? E. You can see the diagram, SP by PM equal to E. That only we are going to use now. The final, let P be any point, let P xy be a point on the ellipse, SP by PM equal to E. So cross multiply, SP is equal to E into PM, square it, SP square equal to E square into PM square. So still I want SP square, you can use distance formula. SP, S and P, you know both points, you can use distance formula. SP square, so don't put root. PM square, so I want PM. See the diagram? What is PM? We drawn from P, you draw a perpendicular. Okay, so PM is same as what? NZ. PM is equal to NZ. NZ we don't know, so if you don't know, you write in terms of C, that's all. How can you find NZ from C? CZ, right? I want that NZ, right? So NZ can be written as CZ minus CN. CZ minus Cn. What is CZ? A by E. Just now we proved. For that one we proved all these things. Minus Cn. Can you tell me what is Cn? See the diagram and tell me which length is Cn. Cn is this length, right? That is x coordinate. What's x coordinate? X. So Cn value is what? X. So A by E minus x. PM is equal to A by E minus x. I derived here. And take LCM, you are getting E LCM A minus XC or EX. Okay, now you substitute everything here. SP square equal to E square into PM square. SP square distance formula you have to use. SP square. sp square, distance formula use x minus ae the whole square plus y minus 0 the whole square. X minus ae the whole square plus y square equal to e square into this e square you are writing, okay, e square into pm square. This is pm square. So numerator square, denominator square, right? Now you can cancel in both the cases, you can cancel what? That e square you can cancel, right? So when you cancel that e square, so what you get? The remaining left side you expand it, a minus b the whole square, a square minus 2ab plus b square. Write this y square. Right side a minus b the whole square, a square minus 2ab plus b square, right? So now in both the sides, what you can cancel, you see? Which term you can cancel in both? You can cancel 2aex, minus 2aex cancel on both sides. Now x square terms you combine this x square, bring this minus x square e square to the left side. So you will get minus x square e square plus y square, okay? Now the remaining, take it to the right side. Already one a square is there, okay? And this plus a square e square, take it to the right side, minus a square e square. Now in these two, you take x square outside, 1 minus e square plus y square equal to the right side, you can take a square common, right? Now I want to make this part as 1. So by that you divide. So dividing by a square into 1 minus e square. So when you divide by a square into 1 minus e square, the first one, this 1 minus e square get cancelled, right? 1 minus e square get cancelled. So x square by a square, x square by a square plus second one only y square is there, so nothing get cancelled. Y square by, write the whole thing. What is that? A square minus e square. The right side everything get cancelled, so you are getting what? 1. Okay, so this is what you are getting. Now what we do now? So for this denominator, this we give a name. A square into 1 minus e square. For this only we take it as what? B square. We take that as what? B square. So the equation is x square by a square plus y square by b square equal to 1. Remember where b square is equal to a square into 1 minus e square. So this is the derivation of ellipse. For the examination point of view, it's up to you. You practice it. But see, a lot of results we derive, right? So much you learn from here. So one derivation if you go through, so we learn quite a lot from here. So I'm advising you to go through this, write and see 2-3 times. Okay, just briefly I'll explain to you one more time. Hope you understood the diagram. First what we do now, just a dash is equal to 2a. C is the center, it is 0, 0. A dash is the major axis, b dash is minor axis. First a is a point on the ellipse, right? A is a point on the ellipse. So SA by AZ is E. Cross multiply one equation. A dash is a point on the ellipse. So SA dash by A dash is Z. Same Z only at A because I am using only that focus S. Focal property, that is different one. Both the focus you have taken, right? When you take S, use that directrix. When you use S dash, use that directrix. But here we are using only one focus, S. So SA by AZ, SA dash by A dash is Z only. Cross multiply. Adding them, you are getting one result. Subtracting them, you are getting another result. So from that, you know what is focus. Then you take a point P, apply the condition SP by PM equal to E. PM you find separately, just substitute, simplify, you will get the answer. And A square into 1 minus E square, you take it as what? B square, okay? So B square equal to A square into 1 minus E square. So this result you remember. So I'm encouraging you to learn this result because why, you know? So whenever, sometime they will give a question, x square by 25 plus y square by 16 is equal to 1. Find the eccentricity. You know, this is first type or second type? First type because greater, smaller, first type. So what is a square? 25 and b square is what? 16. Once you know a square, b square, substitute, you can find what? E square, right? From that you can find the eccentricity. If you expand it, a square into 1, a square minus a square, e square, and a in the book they given us what? C. So you can use the letter what? C square and try to remember this also, okay? Then just I want to take lattice rectum, you know, just to go a little fast. Lattice rectum, what is lattice rectum? You know, perpendicular focal chord. When I teach parabola, I explain that. So through focus, you draw a perpendicular line. So here, length of the lattice rectum, equation of lattice rectum, endpoints of lattice rectum. Since there are two foci, there are two lattice rectum, right? Can you say equation of lattice rectum? So this is one lattice rectum and here you can say another lattice rectum, right? This length is what? AE, parallel to y-axis, so x equal to constant, right? So the equation is x equal to AE, one lattice rectum, another one x equal to minus AE. Okay. So how can you find the length of the lattice rectum? You find, I'm taking this length as y1. So this point is AE comma y1, right? AE comma y1. So find y1, double it. You will get length of the lattice rectum. So you start with equation of ellipse. So this is equation of ellipse. It passes through the point AE comma y1. Just to substitute and you can find the value of y1. Okay. So some substitutions, this 1 minus e square, I substituted the value from where b square equal to a square into 1 minus e square, right? So 1 minus e square is same as what? B square by a square. That value is substituted. So when you take square root, you get this result. You can go through the proof later. So this is y1, but length of the lattice rectum means 2y1, right? So multiply by 2 b square by a. For parabola, length of the lattice rectum is 4a. But for ellipse, it is 2b square by a. For both the types, there are two types of ellipse. For both the cases, length of the lattice rectum remains same. N points you see 2b square by a, right? So this is AE, b square by a, because half of that, y1. y1 value is what? B square by a. So this is one end. Can you say the other end? Same, x coordinate same, AE. Since the y coordinate is the fourth quadrant, you write minus b square by a. I'm taking this is L1, L1 dash. Can you say the coordinate of L1? Left side. So minus AE, right? So minus AE and the y coordinate is b square by a. And for the last one, minus AE and third quadrant, y value also negative, minus b square by a. Okay, so like this you can find the end points of lattice rectum. So what is lattice rectum? What's the equation? What's the length? The end points of lattice rectum. What is the distance between two lattice rectum? Same as distance between two foci, right? It is 2AE. Distance between two directrix, 2A by E, right? So remember all these things, then it will be very, very easy only. See the results, we go a little fast, how to write the results. So first type, x square by greater, y square by smaller, right? That is the first type. And this greater value only we take it as what? A square, and this is our b square. And here x square by smaller value, and here greater value. And this greater value you take it as a square for the second type. And this is what? B square. Center, first I'm going to give the results using what? 0, 0. Center is 0, 0. Vertex a, 0. Vertices minus a, 0. Focus AE, 0. That AE only we take it as what? C, right? C, 0. Minus C, 0. Remember where C equal to AE. Okay, so that you remember. Length of the lattice rectum, 2b square by a. Just now we proved. Equation of directrix, x equal to a by e and x equal to minus a by e. Equation of lattice rectum, first one is equation of directrix, right? Equation of lattice rectum, x equal to ae and x equal to minus ae. Length of the major axis 2a, length of the minor axis 2b. This is for the first type, right? Equation of major axis for the first type, which is major axis? X-axis. X-axis equation y equals 0, right? Y equal to 0. And equation minor axis is y-axis. Y-axis equation x equal to 0. Okay, these are for the first type. For the second type, what changes you have to make? Center is what? 0, 0 only. Vertex, so you see the diagram how it is. Vertex means these 2 points, right? On y-axis. So 0, a, 0, minus a. Focus 0, C, 0, minus c. Length of the lattice rectum remains same, 2b square by a. Equation of directrix, instead of x you put y. Y equal to a by e, y equal to minus a by e. Then equation of lattice rectum, instead of x you put y, that's all. So y equal to ae and y equal to minus a. Length of the major axis 2a, 2b, everything. Length remains same always. Length of the lattice rectum, everything same, right? So major axis, minor axis now changes. For the second type, y-axis become major axis. Y-axis equation x equals 0 for the second type, okay? And here y equal to 0. So this is the basic one. These are the results when the center is what? 0, 0. If the center is at h, k, what changes you make? So add one h. a plus h, and 0 you add k. So here minus a plus h, and y coordinate you add k, 0 plus k, it is k. So focus, h comma k you have to add. So with x coordinate c plus h, y coordinate add k. So here minus c plus h, 0 plus k. Length of the lattice rectangle remains same. So for equation of directrix, x equal to, so for x you add h, for y you add k. So x equal to a by e plus h, and here also x only, x equal to minus a by e plus h. Don't add k. Some of you may think first you add h, second k. No. In coordinate, okay, x coordinate, y coordinate. Add h, add k. But this is x value only, right? Then equation of lattice rectum, again x equal to ae, since it is x value, plus h. And x equal to minus ae plus h. Then length, there won't be any change. Length of the lattice rectum, major axis, no change. Now for the second type, center is h comma k. When the center is h comma k, so the vertex add hk. So 0 plus h, it is h, a plus k. Here again 0 plus h. So 0 plus h is what? H, comma minus a plus k. And here x value add h, so 0 plus h, it is h, c plus k. So here also 0 plus h, it is h, minus c plus k, y coordinate add k. Then length of the lattice rectangle remains same. Now equation directrix, it is y value, so y value add k, right? So y equal to a by e plus k, and the second one y equal to minus a by e plus k. And here again y equal to ae plus k, y equal to minus ae plus k. So hope you understood all these things. Equation of major axis, minor axis, that also corresponding changes we give. So that's all the basics of ellipse. So standard equation of the ellipse, and the b square value, remember, a square into 1 minus c square. Then focal property we studied. Sum of the focal distance equal to length of the major axis. Then length of the major axis 2a, length of the minor axis 2b. Then lattice rectum, length of the lattice rectum, the proof. Then the derivation, all the results for the two types. So remember how to identify the two types of ellipse. Go through all these results. Then the next class, the sums will be very, very easy for you. We'll continue the next class.